All right, well, thanks everyone so much for joining us tonight. This is our fifth and final webinar in the Improve Your Home Energy Efficiency, the Retrofit Journey series. For those of you who are joining us for this first time, my name is Jenna. I'm a Built Environment Initiatives Coordinator with the Community Energy Association, and I'll be facilitating tonight's webinar. So tonight's session, Heat Pumps, Everything You Need to Know for Your Home, will be presented by Rob Pope and Ryan Coleman of Ecolighten Energy Solutions, and they'll introduce us to the basics and benefits of heat pumps with ample time for discussion and your questions at the end. Perfect. So I'm joining tonight from what is now known as Nelson, but for thousands of years has been the traditional homeland of the Snakes Nation, the Silks Nation, and the Tanaha Nation, and is home to the Métis and many diverse Indigenous peoples. I'd like to express my sincere and deep respect and gratitude for their generations of stewardship over the waters, mountains, and forests of this area and across Canada. As part of CEA's commitment to truth and reconciliation, we recognize the importance of amplifying Indigenous climate leadership. So I just wanted to start off tonight's session by highlighting a project aimed to equip all community members with heat pumps in their homes. So Sikadek is a community of the Gitxsan people in the Hazelton area of Skeena Country of northwestern British Columbia. So the community is located on the west side of the Skeena River between Hazelton and Kispiox. It's small but vibrant and resilient community that seeks healthy, safe, and positive development that is sustainable for future generations. So the Sikadek Band, also known as the Glen Vowell Band, received $300,000 in funding through the BC Indigenous Clean Energy Initiative to help improve the community's energy efficiency. The funding is being used to install heat pumps in 70 community homes. And with the completion of this project, all 75 homes in the community will have a heat pump. So if you'd like to learn more, there's a couple links at the bottom of the slide there, and we will be sharing the slide deck out. So feel free to go learn more about Glen Vowell Band or their clean energy initiative. Perfect, thank you. So for those of you joining us for the first time, the Community Energy Association, or CEA, we are a registered charity and nonprofit. We're committed to advancing bold climate and energy action by local government and Indigenous communities. And we're proud to be the only nonprofit in BC dedicated exclusively to supporting these communities and their efforts to tackle climate and energy challenges. Our team of 50 staff members is spread across 27 communities in 5 provinces and territories. And CEA recognizes that the built environment is a significant contributor to greenhouse gas emissions. And by addressing this sector, we can achieve meaningful emission reductions, strengthen community resilience and energy security, and enhance the comfort, health, and safety of our homes. And then just one final slide from me before I pass things over. So CEA, we are involved in a few different initiatives around building capacity in the building industry across BC, and the Kootenay Clean Energy Transition, or KCET, is one of these initiatives. So the program was designed to support the shifting landscape of energy efficiency, renewable energy, and improved home comfort. And through KCET, we strive to help Kootenay and boundary communities prepare for a more energy efficient, comfortable, and healthy future. We offer training and capacity building sessions for building professionals, as well as community workshops in high performance building like the one that we're hosting today. So thanks to the generous support of the organizations listed below, we're able to provide these workshops at no cost, working alongside industry experts. All right, so I'm going to pass things over, but just a couple keeping items. If you have questions during the session, feel free to raise your hand, your virtual hand. You'll see it underneath the React button on the bottom of your screen, and I'll call upon you to ask your question directly to Ryan or Rob. Alternatively, feel free to put your question in the chat and I can ask on your behalf. Tonight's session is being recorded. We'll share a link to the recording along with a copy of the presentation slides early next week. And that's it from me. It was my great pleasure to introduce Rob Pope and Ryan Coleman of Ecolighten Energy Solutions. So Ecolighten is an energy services consulting and home performance design company consisting of a team of HVAC design specialists, energy efficiency consultants, and project managers who are committed to finding the most cost-friendly, energy-efficient solutions at every turn. So we're incredibly lucky to have Rob and Ryan here with us this evening, sharing some of their knowledge with us. And with that, I'll pass things over to you.
Well, thanks, Jenna, for the kind introduction. Everybody's getting 2 for 1 tonight. So Rob and I are going to tag team tonight's discussion, and we're happy to take questions as we go. So if you just want to raise your hand or put something in the chat and Jenna can moderate, we're we're more than happy to answer your inquiries. So tonight, yeah, so we're really pleased to talk about heat pumps. It's something that's kind of near and dear to our heart personally, both from helping with programs and policies to facilitate heat pump adoption in British Columbia, and then also we have one of the Canadian subject matter experts here on the call with Rob, who installed some of the first technologies in Canada, and I'm happy to people to try to stump him tonight with their question. So the agenda, we're just going to talk about what heat pumps are, go through a few different types of heat pumps and applications, and then spend a lot of time talking about tips for a quality installation. So we spend a lot of our time actually working on the industry side of the equation. So working directly with contractors and Jenna and other local governments in the province and the utilities, trying to facilitate best practices when it comes to heat pump installations. And one of the areas where we see there being I guess vulnerabilities, for lack of a better term, is homeowners being able to best manage their contractors to get the intended outcome of their investment. So we want to really talk through kind of like how you can arm yourself with the right questions to ask contractors, and just be really confident that when you're making that investment in heat pump technologies, you're getting the best possible outcome. And so, we don't want to go deep into the technical weeds, but we want to make sure that you're, can have some confidence that when you're speaking with contractors, you can ask the right questions to get the best outcomes, and then identify some resources that may be able to assist you with planning your heat pump retrofit. And then, as I said, question and answer session, but we're happy to take questions throughout as well. So in terms of what is a heat pump? So this is really a proven technology. It's been used for decades, both in Canada and globally, to provide heating, cooling, and even domestic hot water in houses. And the basic concept is during the warmer months, it's able to provide cooling by transferring heat from the warm air indoor to the outside of your house. And so it's a heat transfer mechanism. And then during the cooler months, what the heat pump does is it extracts heat from the outside air, and then it uses electricity to increase the temperature of the heat and then transfer that inside your home. And the best performing heat pumps, if you want to look at it, they'll take 1 unit of energy and turn it into 3 or more units of heat. In terms of types of heat pumps, we'll start with the all electric ones. So this is the most common. Air to air heat pumps are the most common technology. There's really 3 types of air to air heat pumps. The first is your centrally ducted heat pumps. So these are ones where the heat pump is distributing heating and cooling through ductwork that is connected to vents or ductwork and grills inside your house in each of your home. And then the second type is what's called a ductless heat pump, and this may be in a mini split, multi-split, or even a concealed ductless configuration. And so what ductless units do is use 1 or more indoor heads that are located in the home to distribute the heating and cooling. And then a concealed ductless heat pump will use short ductwork runs that connect a single indoor unit to multiple rooms in your house. And then the third type, which is really common as well, and especially in colder climates, is what's called a dual fuel or a hybrid heat pump. And basically what this does is it combines an electric heat pump with a gas furnace. And so as the outdoor temperature changes, what the system has the option to do is alternate between the 2 fuel sources. So depending on what that switchover is, it's intended to maximize comfort and efficiency, while also providing the benefit of using both of those fuel sources. So as I mentioned, the dual fuel system incorporates what's called a switchover from the actual heat pump to the furnace operation. And they typically utilize 1 of 2, and sometimes both, control technologies. So the first one is it'll have what's called a deviation from the set point in the house, which can be anywhere from 1 degrees or 3 degrees Celsius. And if the heat pump is not able to hit that set point within a certain amount of time, it'll recognize that it can't keep up, and it'll switch over to the gas furnace. And then the other technology from a control standpoint that it'll employ is a temperature sensor. And so that might be an outdoor temperature sensor, or it might be information from a Wi-Fi. Oopsie. It might be information from a Wi-Fi thermostat, or a Wi-Fi thermostat that takes local weather station data. So for example, you may have heard of like ecobees and nests. So what they'll do is they'll use the temperature from a local weather station to determine what the outdoor temperature is, and then thus have a switch over utilizing that.
Hey, Ryan,
then,
just a
yeah,
quick question there on those dual fuel heat pumps.
sure.
Just in considering or knowing that that the cold climate heat pumps exist and that can work down to negative 25 degrees, why would we choose to go with a dual fuel heat pump rather than a cold climate?
Do you want to start on this one, or you want me to, Rob?
I'll answer it. See, I told you, Jenna, when it gets contentious, that's when I take.
First fuel switching question. You're down, Rob.
Well, there's first of all, yeah. So not cold climate heat pumps. Some of them can go down to as low as minus 25, but not all of them. If you're going to choose a heat pump that can go down to those kind of sub-zero temperatures, you're buying a high quality heat pump probably, right? So there's a cost involved, a cost implication, which might be fine, might be just worth every penny of it. The other thing is that there are some climate zones and regions in the country that actually have climate winter conditions that are lower than that, and so even the best of them won't keep up during the extreme winter conditions, and so you need something. And that something can be electric strip backup or a gas furnace. And the choice then becomes whether or not, especially in a retrofit, you have enough service capacity on your electrical panel to take on all that extra amperage you need for electric backup, where you could just have gas. The other thing too is in some areas, you're far, it's 2 hours or more to get a technician to come, if you can get them from the nearest town or a major center. And in those situations, your gas furnace then becomes a backup source of energy. So you can wait it out. If something happens to your heat pump, you're waiting for a part, your gas furnace will take over and do the work until it gets sorted out. So there's a number of reasons for that. There's also currently, I believe, and correct me if I'm wrong, Ryan, there's a $10,000 grant from Fortis to do a retrofit, to take whatever you've got in your basement, take it all out and put in a new high efficient gas furnace and associated heat pump with it. So there's quite a range of reasons why you would consider gas as a backup.
Yeah, the only other one I would add is depending on the heat loss of your house and the capacity of your ductwork, and we'll talk about this, you may not be able to size a heat pump that can still have the capacity to provide the heating for your house down to those temperatures. So in those cases, you're going to need something. So as Rob was saying, you can do that with an additional electric strip heat, or you can have the gas furnace act as a backup. So these are the types of considerations that go into all electric or dual fuel applications. And then but I guess a lesser common heat pump system is ground source heat pumps. So this utilizes the moderate temperature of the ground to have a high year-round efficiency. And these can be in ground source or ocean source or lake source geothermal systems. And these have a significantly higher upfront cost than your air source heat pump. So you typically see them utilized, I guess, in more so like estates or commercial applications. Would you say, Rob? Is that fair? Can't see you.
Oh, sorry. Yeah. No, that's absolutely, correct. they're quite expensive, and they don't have a life cycle payback they used to, because there was a time when air source heat pumps were much less efficient. However, the technology of air source heat pumps has come to the point where they're no less efficient than ground source heat pumps are nowadays. So with ground source heat pumps, you're really paying a premium for about the same value when it comes to operating efficiency.
And then, yeah, and then the last technology that's becoming more, I guess, available in our market compared to previous years is air to water heat pumps. And this is for homes with hydronic systems, where it transfers the heat from the outdoor air into liquid distribution, so water. And this can be used both for space heating and cooling, as well as domestic hot water, or all three applications at once. Approach to auxiliary and backup heating. So this is, as Rob was hinting at earlier, so for centrally ducted heat pumps, supplemental heating is when the additional heat that is needed if the heat pump is not able to keep up with the needs of the home during peak conditions. So with the newer types of heat pump technologies, the electric resistance heating can actually stage on in increments, so it's not necessarily pulling the full amount. So that's actually a good kind of benefit. But it's provided by electric resistance heating, so you lose sort of like the coefficient of performance. Instead of it being 3-to-1, it's just the 1 now. And then with dual fuel approaches, the supplemental heating would be with a high efficiency furnace. One important distinction with the all electric and the dual fuel too is with the all electric, as we were mentioning, you can stage on to really supplement the heat pump when it can't keep up. But with the hybrid dual fuel solution, it's really an on or off situation, where either the heat pump's working or the gas furnace. So you don't run both of them at the same time. One thing we do find in the industry, and this is directly with contractors, is there's a lot of confusion between the terms of like backup or emergency heat versus supplemental heat. And so, we'd like to draw the distinction there so that folks aren't using those interchangeably, where supplemental and auxiliary is the heat that has to come on when the heat pump can't keep up, like we're talking about, to meet the heating needs of the home in colder weather. And then backup emergency heat is really the heat that should only come on if there's a failure of the primary heating season. But we like to keep the distinction there so that folks understand the differences, especially when you're in rural, remote communities, as Rob hinted at earlier, where you'll typically have backup heating systems because you don't have access to contractors and things to solve issues when you have equipment that's down or needs to be serviced. Getting into the homeowner tips to a quality installation. So this is actually like a business philosophy of ours, because we do design systems as well, is looking at it not from the box itself, but really like what's the process and the steps and the sequencing to deliver optimized performance. Because simply expecting the equipment to operate like a refrigerator where you plug it in and it's going to work to what it says on the rating plate, doesn't work that way when it comes to space heating and cooling systems. And it really depends on making sure that the system is being properly sized, that it's being installed to an acceptable standards of practice. And then one of the most overlooked components is actually the performance verification and the commissioning of a system. It's funny when we do quality assurance and do field reviews with homeowners, and we ask questions around, did the contractor do a load calculation? And they are asked, what is a load calculation? And we're like, did they verify the performance and show you a commissioning sheet? And it's like, what's a commissioning sheet? These should all be like common practice, so that so the homeowners know that the contractor's done their due diligence when it comes to selecting, installing, and then handing over the equipment to the homeowner. And we've got a little data piece here that really reinforces why quality installation is important, and studies have shown that 50 to 70% of the systems are, and this was not a small sample size, this was a large sample done in North America, are improperly installed, and then the deviation from actual performance is anywhere from 10 to 50%, depending on the issues with regards to design, specification, and installation. So there's a lot of risk, I guess, is the best way to describe it, in getting the right system. And it's not just about buying the right piece of equipment. So the steps that we're going to talk to you about are pre-changeout. So this is really, coming up with the most appropriate strategy for your house. And that's touching on things like the interview with the homeowners themselves and finding out how their existing equipment works, the home performance, and then equipment review and testing, which we'll get into more detail about. Calculations, which is around load calculations. So F28012 load calculations. I see questions popping up, Jenna. So I'll go through these 3-4 points, and then we can take some questions. F28012 load calculations, that's the standard, but it's really about what is the heat loss and heat gain for your house. So on the coldest day and on the warmest day, what do you need in terms of BTU for your home, and then everywhere in between. Balance point calculations. So that's what we were talking about earlier. Well, like, what is that point where the heat pump needs support to be able to provide the space heating requirements in your house, and then how is that actually calculated and not rule of thumbed by the contractor. And those are the pieces that actually inform equipment selection. But the key word there is calculations. It's not about rule of thumb. It's about actually calculating the appropriate solution, which requires some contractors to do due diligence. Third piece here is installation. So again, I mentioned earlier, we try to move people away from just thinking about the box itself, and really thinking about what are the key components around the installation that are actually going to get you that optimized performance. So we're going to talk about, like, how you match the equipment. When you're dealing with existing homes, all homes are snowflakes, and so each one of them may have their own opportunities and limitations, especially when it comes to capacity of ductwork and enhancements that might be required to optimize performance. Things that can be done in terms of improving distribution systems. Filtration, that's a often overlooked one, where people talk about, I'd like to have really good indoor air quality, and I have sensitivities around particulates, and then contractors will go and put in filters that really have no really good filtration properties, when they could be putting in something that's more appropriate to the needs of the homeowner. And then control configurations, what's the proper controls, how do you make sure they're wired correctly, and then how is the homeowner educated in terms of being able to operate their system in an appropriate manner. And last one is commissioning. And so there's kind of like two components to that. One is like making sure that before the contractor leaves the home, that they are verifying the install performance of the system and making sure that it matches manufacturer expectations and ratings, and then the education piece. So it's not just like handing over the keys. It's about like making sure that folks understand how their system operates, how the controls are configured, and then what do they need to do in terms of preventative maintenance and servicing to maintain kind of warranties and things. So maybe I'll pause there and we can take some questions.
Sure. Thanks, Ryan. This question, maybe you feel free to address it now, or we can save it for the Q&A after. But Chris was just wondering about recommendations for a DIY installation.
Don't.
Yeah. I think we should save that for the Q&A, because I'd like to know what technologies they're thinking about there. Okay. Bonnie just shared a story. Sorry, Bonnie, that sounds awful, about her experience with a poorly installed system. So those, what Brian was saying there about people going through kind of terrible experiences with heat pump installs is reflected with even people on the call here. So sorry to hear about that, Bonnie. And Lori just asks, just with this in consideration about the poorly installed systems, how can a homeowner trust a contractor or find a quality contractor? So we can talk about that. We could save that one for the Q&A too.
Okay.
because we're gonna share. So on the first part, we're gonna share some resources, as well as Community Energy Association has some really great like info sheets and things that homeowners can access to support them with like the procedures and the questions for contractors. And then we have some other ones there, and then we can talk about where to go to look for contractors. And maybe Rob, you can share some tips about like things to look for in terms of like training and qualifications and experience, and really kind of testing them in terms of making sure that they are going to follow the appropriate steps.
Mhm.
Okay. Step one, pre-changeout procedures. So this, again, as I was saying, is about understanding the existing HVAC system. As much as it's as important to like before you put, or I should say, it's very important before you even think about installation, understanding how your existing system is working and your overall home performance, because that's going to inform the heat pump sizing and equipment selection. So there's really three main pieces to this recipe. And we'll talk about each of them in detail. One is like an initial interview with the homeowner. The second one is getting a good understanding of your existing home performance and house as a system, and how is your envelope, air tightness, and other things actually performing. And might it make more sense to invest in some envelope work before you actually get the heat pump, so that you can properly size it and it makes sense for your house. But we'll talk about that in a second. And then the last one here is about really looking at the existing equipment, and this is for the contractors. How are they looking at the existing capacity of the ductwork and distribution system to inform what the capabilities are for the new equipment that's going in. And again, that's not just about going in and having a poke in your head in the mechanical room and looking, do I have enough space? It's about understanding some of the data, collecting some data and airflow information to make informed decisions. So this first piece, homeowner discovery, we like to call it homeowner discovery. This is about gathering information from the consumer to better understand expectations and needs. This is often overlooked to support the decision making and recommendation on a heat pump. When we talk to homeowners about the quotation and the kitchen table discussion with the contractor, it's a lot about like features and benefits and costing of systems, but it's not necessarily a lot about understanding the experience with the existing HVAC and distribution system, like asking them about temperature differentials in the home and back bedrooms and things like that, and like is there an even level of comfort in the house, because that can inform is there existing ductwork issues that need to be investigated further by a contractor, or is it noisy already and you're going to be putting in a piece of equipment that is probably going to operate at a higher CFM, so it's actually going to make it could potentially make the noise situation in your home worse. So understanding that and asking questions about the experience with the existing equipment is really important. We talked a little bit about this in terms of motivations, like what the motivations are for a heat pump system. So is it to get cooling? Are you motivated because you want to access an incentive and you think it's the right time? Is it more an environmental reason and you want a fuel switch and do your part for utilizing less carbon intensive technologies? But all those things can inform the right recipe for your choice of equipment. And then you're now gonna, like, if you're going from just a gas furnace to a heat pump, you're now dealing with both indoor and outdoor equipment. So one of the considerations you need to think about, and this is something that we've been working a lot on, especially in some of the local Lower Mainland municipalities, is trying to figure out what are the appropriate locations where you can put outdoor units, and make sure you're not infringing on your neighbors, and making sure that you have proper clearances and mitigating against any noise, not encroaching on some of maybe your aesthetics in your backyard and stuff. So you want to have a strategy with your contractor, so they're not just showing up and putting the equipment where it can be placed, and then you're disappointed seeing refrigerant lines running around your house and things like that. Like the design strategy is very important to get from your contractor, so that you're not disappointed. Home performance, so I mentioned this is about determining any completed or planned upgrades, especially with existing homes, because this is going to influence your equipment sizing and selection, and whether or not you prioritize other upgrades happening in your house. So if you've upgraded your windows and your insulation, and your contractor isn't looking at or using that information to inform their load calculation, they may be oversizing your system, or in some cases they may be undersizing it if they aren't collecting that data. Or you might be planning some of this, so you might want to build in some resiliency or be able to accommodate with like modulating equipment, where maybe it might be like slightly oversized. But when you make the upgrades, because it's a modulating technology, it's able to ramp down its capacity with what you're when you're getting your upgrades. So, anyways, bottom line is like understanding the existing home performance and sequencing of upgrades, and any sort of planned work is really important outside of just your heat pump and the equipment you're selecting. And then the last one is the performance assessment. And so this is a bit more on the technical side, I guess, but contractors, aside from like collecting the data to do load calculations, understanding how your existing equipment is performing from the homeowner's point of view, they really need to be doing some data collection and performance testing of your existing system to determine any type of limitations or issues with putting in a heat pump within an existing home that has existing ductwork capacity. And again, that's about like, doing actual testing, like static pressure testing or airflow testing in the case of having like a flow grid like we do in this picture, that can really inform your decision making about whether you need ducting enhancements or whether you have any limitations with the actual heat pump that you can size for your house. But again, it's not a visual piece, it's actual collecting of data to make that informed decision. So those three pieces are really the critical parts of proper pre-change out that homeowners should be expecting, or at least asking their contractor to participate in as they're doing this.
Hey, Ryan, just a quick question
yeah.
on that. Sorry to interrupt. Could you explain why the airflow may need to be higher with a heat pump versus a gas furnace in the duct system?
It may not need to be higher, but a gas furnace without a coil that is attached to a heat pump will have a lot less resistance. And so it can deliver more heat because it's only going through a heat exchanger. Since you put a coil in that ductwork, you're adding a lot more resistance. So that's one thing. The other thing is, in order for the refrigerant to do its job, it has to change states. It has to go from a gas to a liquid and back and forth, depending on the season. In order to do that, it needs a certain amount of airflow. Nominally, it's about 400 CFM per ton. Every 12,000 BTUs is a ton, and there's about 400 CFM, give or take, depending on the equipment, a little less or a little more. But for example, if you do the test that we showed on the last slide, and what you're measuring is the ability to drive air through the ductwork, the existing ductwork. And you may discover that the ductwork, in most cases, existing ductwork is undersized. You may want to put a 3-ton heat pump in there, but really the ductwork only has the capacity to deliver 3.5 or 2.5 tons. You're limited. You can't push enough air through that duct to make a 3-ton system work, right? So that it's not just about you need more airflow. It's a different relationship with airflow when you put a heat pump in. It's a different set of dynamics that's going on.
Great, thank you.
I'm still sharing, right?
Yeah.
Okay, good. Calculations. So calculations starts with load calculations, and there is a CSA standard which really governs proper sizing of residential heating and cooling systems. It's recognized in the BC Building Code as a requirement for new construction, and basically it's the methodology for determining what is the heat loss and heat gain for the home. And so contractors need to know that standard, and they need to be using tools that are verified to meet that standard to do their load calculation to ensure the system is right sized, is going to provide the comfort, and right sizing means appropriate like cost too. In terms of the HVAC system, it's not going to be oversized, and thus homeowners paying for a larger system when they didn't necessarily need it. So it starts with the heat loss and heat gain. We talked about this a little bit earlier, but the second piece of calculation that's needed is what's called the capacity balance point calculation. And so there's kind of two things that go to determining this. One is the heat loss of the house, which is shown here on this line, this orange line that shows the increasing capacity that's needed as it gets colder. And then with heat pumps, their capacity lowers as it gets colder. So at that intersection between where of those two lines is what's called the balance point. So this space between here, when we were talking earlier, this is the supplemental heating that you're going to need, where the heat pump can only deliver this amount, but your house actually needs that amount, right? So again, this is what the important piece of information here is not you being proficient in doing capacity balance points or really understanding the technical nuance and details. The important pieces are contractors should be calculating this based on your home, your location, and the equipment that you are looking to select. And they need to understand that the actual performance of the different equipment varies between technologies, brands, and models. So there's no such thing as the balance point in my area is X or the balance point in my area is Y. The balance point is specific to the house and the equipment that is being installed in the home. And that's a calculated number that contractors should be doing to give you confidence in understanding how low can I run my heat pump? Like, can it cover the heating, or what additional supplemental heating might I need, depending on what I'm able to put into my house? But it's a calculated value.
Yeah, Ryan, can I add?
Yeah, go.
That line C to B, that's the heat pump capacity, and tends to correlate to its efficiency as well. Its capacity will drop off, its efficiency will drop off. That C is at about 48 degrees Fahrenheit. That is the nominal capacity. All heat pumps are at, basically the same line at the starting gate, 48. That's their nominal capacity. So something that says it's a 3-ton is at 48. Unless you get into the cold climate heat pumps, the very high performing heat pumps that are able to maintain their capacity into sub-zero temperatures, most equipment will have a line like that blue one that dips down as it gets colder. Some of them dip down a lot steeper, some of them a little bit flatter. But on the other hand, if you go with some cold climate heat pump technologies, that line, instead of dipping down at all, will be flat all the way down to -15 and then just barely drop off. And you may, in that case, need no supplemental or backup heat. The point is, though, that every single heat pump will have a different curve from 48 degrees to the outdoor condition. No two of them are the same. Even different models within the same brand catalog will all have different curves. And unless you do your research, find out it's not hard to get research, by the way, it's easy. Find what the performance curve is of the equipment you're considering. Then you're really depending on coincidence for it to work.
Nice. Do you want to do the install part, Rob? I feel like I've been waxing lyrical here.
Yeah, you've been doing a great job. Okay. So this is a quote from Tom Tasker, product manager at Johnson Controls. The most important day of an HVAC system is the day it is installed. Proper commissioning of the system is the only way to achieve the efficiency and long life for which the system was designed. it can also be the key to effective troubleshooting later. So let's expand on that. First of all, the day it's installed means, you know, you're installing something. So what are you going to install? What you want to install are systems that are made to talk to each other and work with each other. So in this case here, we're describing it as fully matched versus not fully matched. So, you know, you got three major components to your heating system when it comes to heat pumps. You got your outdoor unit, your heat pump, say. You got your indoor unit, which can be a fan coil or a gas furnace. And you've got your indoor refrigerant coil. What you want to ensure is that all those three major components, plus all the associated wiring and controls and everything, you know, are all meant to talk and communicate to each other, because that way they're sharing data, and that way they're optimizing their efficiency and comfort, as opposed to having one brand of outdoor unit with another brand of indoor unit and yet another brand of a coil or a thermostat. You want them all to match. So that's a first step in having a good quality installation. Thermostats. There's companies out there that have really figured out how to brand their products directly to homeowners. They do a really good job of that. What I would say is that you're better off to ignore all of that. What you really want to do is get whatever thermostat that manufacturer recommends goes with their product. You'll have two general categories of equipment, and it's basically communicating and non-communicating. Communicating is usually the top tier of brands, models that they offer. And what that means is that there's all kinds of algorithms built into the product, into the equipment, that communicates conditions with sensors and all that kind of stuff between the thermostat and the actual equipment outside and in your mech room. And that is the most effective way to optimize performance, comfort, everything. And then there's the other category, which is non-communicating, which means that your thermostat doesn't need to match the equipment. It's better if it does, but if it doesn't, that's okay, because now what you've done is you've reduced your equipment to on and off. You've taken out that data sharing between the operation of the equipment and the ability to use that data with algorithms to optimize its performance. So ideally, you want a matching thermostat. Doesn't mean you have to have it. That's just ideal. The ideal next step in having quality installation. Building penetrations. This goes unnoticed quite often. It's amazing how many times we've seen this. There's a good way and a not good way to do it. Now on the left, you'll see nicely sealed. In fact, the picture on the right of the left, you know, it has a box that is intended for those refrigerant lines, your wiring, everything to go through, nicely sealed in an aesthetically pleasing manner. But more important than anything else is it's nicely sealed. That really matters a lot, as opposed to on the right-hand side there, you know, it's not sealed. And even if it's not sealed well, any opportunity for interior moisture to go from the inside toward outside, get trapped in the form of condensation inside the building assembly, or vice versa, for whatever's going on outside to make its way inside, is a potential issue in many ways. It's going to cause drafts and so on, but it's also probably the worst thing is it potentially can rot that assembly, right? Because once that moisture gets in there, you know, you're basically creating a petri dish for mold and other nasty stuff like that to attach itself to the actual building assembly, your joists and whatever's in there. It'll take the effectiveness of your insulation away and other nasty stuff like that. Having it sealed is critical, very, very important. performance verification and education. So proper equipment selection and quality workmanship are 2/3 of 3-act play. And you got to have that final act to resolve everything. And that final act is commissioning. It's often overlooked as an understatement. We have the hardest time with it. We design systems all the time where it's very clear, it's in the contract even, it's the contractor's job to do the commissioning. It is assumed by the manufacturers and the suppliers that the contractors will do the commissioning. It's assumed by warranty providers that the contractors will do the commissioning. The only place where it's not assumed is in the arena of contractors themselves. Now, I'm generalizing, of course, there's a lot of good contractors that do this, fortunately, but they're a minority. And what that is, it's not just a shakedown. You just install a new system. Maybe there's a part or a component from the manufacturer or the supplier that's not working. You want to find that now, not, down the road late on a Sunday night in the middle of winter. When the homeowner calls you, you want to do the whole shakedown now. So that's part of it. The other thing is you've got a complex system, and the manufacturers engineered the system, manufactured and shipped it with some expectations of you checking, make sure the refrigerant charge is this much, that making sure the gas pressure is, between here and here, making sure that the temperature rise as the temperature coming back from all your registers to the equipment, and the difference between that and the temperature leaving. What's that temperature rise? Makes a big difference. What's the airflow coming out of the registers? What's the overall external static pressure? These are all terminologies that I can see people's eyes probably going sideways, going, what the hell is he talking about? You don't need to know all that. What you need to know is that needs to be measured, and not only measured, but documented. It also gives you a chance to see when you're measuring all these things, if something's out. You go, wait a minute, this is not within range. And then you can discover why and resolve it. So it's not rocket science. Anything can be resolved. It gives you an opportunity to do that. It's also important to document it, because somebody calls me and you've had a system in for a few years, a couple of years, and I've never seen it before. I go there. What I want to see is the documentation. What's our baseline? Where did we start with? What were the pressures and the flows and all that kind of stuff? So I can check it now and see where the variations are and where we've deviated from the baseline. And that will tell me as a troubleshooter pretty quickly, what's going wrong and how to fix it. It's also a requirement in a lot of cases to get your warranty. If you have a compressor failure or something like that, something major, you're going to the supplier or the manufacturer under warranty. They want to know, okay, let's see let's see the commissioning report. Let's see your startup procedures. What was the compressor doing, for example, when you started it up? And that helps them determine whether this is a pilot error or it's a legitimate warranty issue. Believe me, suppliers and manufacturers, they've been getting sick of replacing major components and getting them back to the factory, bench testing them and finding out there's nothing wrong with them. So they're getting a lot more stingy in how they process replacing defective parts.
And I would add, utility and incentive programs are starting to get smarter to this, in understanding that, like, their modeled performance of systems, they need to be better collecting quality assurance, quality control data through actual verified commissioning from contractors as part of incentive programs. So they're pushing the market towards commissioning by making it a requirement for a rebate, thus arming the homeowner to ask the questions of the contractor so that they can fulfill their requirements for their incentive.
And so, as I said before, you don't need to know all these details. All you need to do is hold out your hand and say, give me the commissioning report, right? then, you know, hopefully they'll have done it. If they don't even have something to give you, and then, you know, you've got to be a little suspicious. There's a commissioning report for everything out there. From a contractor's perspective, they're easy to get. It's not as though that they're some obscure piece of documentation that you have to search the planet to find. They're everywhere, right? They're in most installation manuals. You know, usually in the back there'll be either startup checklist, it's sometimes called, or startup procedure protocol, sometimes called, or a commissioning checklist is sometimes called. But there's third-party commissioning sheets that come from places like Fortis BC, for example. In any case, whatever the case, you should, as a homeowner, hold your hand out as you would for the load calculations. Hold out your hand. I want to see those load calculations. I'm paying for them. So I want them as part of my documentation. Oh, by the way, balance point, I want that as well. I know I want to see the equipment selection process that you did to choose the equipment. And when it gets to this final part, that's the same thing you should be doing, is holding out your hand and saying, I'm paying for this, so I want to see it, and I want it on my records, the commissioning report.
These are examples. So one from Fortis, types of things that they should be checking and documenting. This is a good one from the Home Performance Stakeholder Council of a standardized commissioning report with various sort of like data collection around airflows, controls, refrigerant charges, and other things that can be used to verify.
There's lots of them there. Lots of them. Yeah.
Just a quick question there on the commissioning report. Sorry to interrupt. How common is it for the commissioning reports to be given out to clients, to purchasers?
It's extremely rare.
Yeah, it's pretty uncommon. The most common scenarios I see now, and this is Jenna, and that's a really thoughtful question, whoever asked it, is with incentive programs on existing homes. And the thing that's so that's the half glass full perspective. The half glass empty perspective is that when we have conversations with them as part of our quality assurance, it's like, where's your commissioning sheet? They're like, well, I got to phone the contractor, and then the contractor is sending something from the office. So they're scribbling in numbers to fulfill the, and I'm not trying to be negative, but I'm trying to be real. Proper commissioning with data integrity is very rare. The awareness around the need for commissioning and contractors like starting to do it is happening. It's gathering momentum, but we are not at a state now where it's common standard of practice, where really good commissioning and performance verification is happening, and that is a useful piece of information for homeowners. And so we're in the kind of this awareness stage, but the industry is kind of on point that like warranty providers, manufacturers, utilities are all in this kind of coordinated movement to be like, this needs to be done, but it needs to be done well, because you guys we're incentivizing these things, and we're getting warranty claims, or we're paying out rebates from ratepayers and taxpayers. And we want to make sure that equipment that's going in is going to have the persistence of savings, not break down, and we can use that data for measuring actual installed performance. So it's not super common practice, but like momentum is going in the right way. And things like this venue, in terms of just educating homeowners on asking the question, as Rob's saying, is half the battle in terms of holding people accountable to something that they should be doing as part of their service anyways. That was a bit preachy. Okay, let's. I think. Do you want to go through the last piece here, Rob, in terms of?
Sure, okay. Yeah.
I can do the resources after.
Okay. Yeah. So, I come from the technical background as an installer, troubleshooter, way back in the day, from mid-70s, actually, embarrassingly. And one of the common themes is, getting a call that something's not working, and you're sure you did everything right, or you're positive that whoever did do the installation did everything right, and you show up and you find out, yeah, everything was done right except one thing, and that is nobody told the homeowner that if you do this, this is going to happen. You know, they either usually it's something to do with the thermostat, almost always something to do with programming or modes, you know, heat mode, cool mode, changeover mode, fan on mode, fan off mode, those kinds of things. There's a lot of choices with thermostats, and it gets confusing. It's got to be made very clear. And before you leave, you got to feel satisfied that the homeowner is understanding it and gets it, because otherwise that can turn into a cold night. You know, like I say, on a Sunday, for some reason, that almost always is when it happens. There's also things like expectations for maintenance. You know, you get there's an issue, the heat pump's not keeping up for some reason, and you go there and check it out. You pull the filter out, and it hasn't been changed, it hasn't been cleaned. It's the same one that was put in there at the beginning, and now it's loaded with particulates, and it's restricting airflow so much that it's affecting the performance of the system. It's creating noise, or it's not delivering the heat. The refrigerant's not changing states adequately. You know, there's all kinds of issues that can come with that. Not to mention that it's not good for your lungs, you know, that indoor air quality piece. Things like you got to put that outdoor unit somewhere. And in a lot of BC, it's not a radical idea to assume that it's going to probably be somewhere near where leaves or pine needles or something's going to be falling on that equipment. You got to make sure the homeowner understands there's a responsibility, whether they do it themselves or contract somebody else to do it, is to keep that equipment clean, to keep the pine needles and leaves and other debris that might fall on that outdoor unit off the unit. Also, this is where the filter is. This is where to get them. This is how you change it. You know, both for whether it's a gas furnace or all electric fan coil. Here's all the documentation. Here's the warranty stuff you'll need to fill this, that, and the other thing out. And we'll send, you know, put your signature on it. We'll send it in. If depending on the type of equipment, sometimes you have to send it to the manufacturer. And basically answer whatever questions, you know, what's this thing here? That's your coil. You got to make sure that hose isn't interrupted or disrupted by you shoving some storage, you know, baggage, luggage, or whatever in the way, right? Keep it clear, you know, and don't interrupt the flow of the condensate drain, for example, things like that. All these little details. The homeowner education is pretty critical. It'll save you as an installer some issues. It'll save the homeowner some stress, you know, and it's a win-win situation. It's really important to understand that the homeowner just spent a lot of money, and so they're entitled to get that that final piece.
A good one, not to go into the super technical weeds, Rob, but maybe you can comment on the expectation or the understanding of like the need for defrost in some situations where it's really cold, because homeowners don't realize that, and then they're like, okay, why is my heat pump, you know, going into cooling, right?
Right. Yeah. It'll go, because what happens is it's cold outside. It's middle of winter, and if it's, you know, at the temperature where things will freeze up, all the moisture out there will freeze up on that outdoor unit, and so it can sense that. It doesn't have a problem. The equipment is clever enough to know when that situation occurs, and what it'll do is it'll go into cooling mode, which means instead of absorbing heat from outside and bring it into your home, it's going to absorb some of that heat in your home and deliver it to that outdoor unit. It won't discharge it to the air out there, and usually you'll switch off that outdoor unit so the fan's not running, just to defrost. Yeah, and they do it in different algorithms, time, temperature, but occasionally you may notice, you may happen to just be paying attention at the time when that defrost occurs. And if nobody's told you about that, that could freak you out. So it's important to let the homeowners understand that this is going to happen. It's no big deal. It's not going to interrupt your comfort level. It'll always, the equipment is smart enough to know what your comfort setting is and maintain it while doing the defrost.
Yep, good one. Okay, so we were talking earlier about resources. So there is some really, depending on technical interest and proficiency, there's everything from just, arming you with the right questions down to like educating you for like installation practices. And so there's lots of really good resources that are out there and available through Community Energy Association. I know you guys produce some good homeowner literature and guides. This is an example here with the Home Performance Stakeholder Council, the best practices guide for installation for existing homes. So it provides some of the steps in more technical detail than what Rob and I were talking on about, like what are those standards of practices that need to happen to get good quality heat pump installs, as well as tools for contractors to use and homeowners to use. That's a really good piece of literature. This is a bit more on the sort of the geeky side of things. Enercan has published a heat pump sizing toolkit and a new app, which helps contractors in terms of making informed decisions around equipment sizing and selection. It's a really cool for contractors as a resource. Local efficiency partnerships. Again, this is an Enercan resource. These folks are about capacity building and best practices and scaling up sort of like good standards of practices across industry, both in new construction and in retrofits, specifically around heat pumps and deep energy retrofits and high performance houses. They have a series of videos that are both for like contractors, builders, as well as homeowners to understand the interrelationships there and some of the things of how they collaborate to get to good outcomes. But it's really written, those videos are really through a not too technical lens. But they can help you in understanding or educating yourself on what the expectations should be when you're working with a builder or a renovator or an HVAC contractor to do a heat pump retrofit. And with that, we'll save it for the questions.
Awesome. Just while we're talking about resources, do you want to touch on that question about how can homeowners find qualified contractors?
So I'll do the first part, Rob, and then you can talk second part. So there's a few different ways. So obviously there's minimum trade qualifications and things like that that contractors must and should have to install systems. From a professionalization standpoint, the heating association in the two heating associations in Canada, the Thermal Environmental Comfort Association, as well as the Heating, Refrigeration and Air Conditioning Institute, HRAI. That's right. Both provide really good industry training to skill up contractors in terms of load calculation tools, understanding airflows, understanding heat pump installs, understanding hydronic design. Rob's one of the authors of these courses and taught for a number of years on it. So we're giving it a plug too. But contractors can access those. The Home Performance Stakeholder Council is a nonprofit association that's been organizing various sectors within the energy retrofit industry and supporting them with training on both like program requirements, but also best practices, and also documenting what those contractors have in terms of minimum qualifications, as well as best practices. And folks who want to access rebates are now having to use contractors who are registered with the Home Performance Stakeholder Council to do the installs. And then, and I'll let Rob talk more about maybe the technical trade side of things if you want to. But like referrals and homeowner experiences and things like that are also ways to help vet the contractors as well.
Yeah, I think if you take what we've been saying in this presentation and just take a few things from it, you can really vet your contractors right away by asking them, how are you going to evaluate the existing system? Are you going to do a load calculation? Are you going to do balance point calculation? Will you do commissioning and document that commissioning? In just less than 30 seconds, you can find out a lot about whether that contractor is answering those questions in the negative or the affirmative, right? Now, granted, there are some regions in the province where everybody that's sitting across from you is going to say nope, 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 and nope, right? To all of those things, and that's really where you're most vulnerable. But in most places, I would just keep searching until you find a contractor that is going to answer those all in the affirmative. They might say, listen, I can't do a load calculation until I have the contract. Fair enough, right? It takes work, but will you provide it? Yeah, that's all you want to know, right? And other than that is going through the Home Performance Stakeholder Council directory. BC Gas has a directory, or Fortis BC has a directory. Jesus, sorry, Ryan, I've forgotten what they're called now.
Trade Ally Network?
Yeah, trade allies. Anyways, so contractors that are associated with one of or more of the trade associations that Ryan mentioned, TECA, which is Province of British Columbia's organization representing contractors, that they're certified, right? TECA, TECA. You can just look on their website for, they'll have a directory who's certified for what. HRAI, which is more of a national organization representing contractors, same thing. Then the Home Performance Stakeholder Council has a directory, and so on. So I mean, you want your contractors to have some association, some skin in the game with an industry, right? And then those questions, how will you assess the existing system? Will you do a load calculation? Will you do a balance point calculation? And will you do commissioning and document that commissioning?
Yeah, and I would just add too, there is really good contracting that's happening out there, and really great contractors. And the intent of the information that we're sharing tonight is to help you identify, to make sure that you're working with those folks. And because the playing field is a little bit uneven, and so we want to help you get to the folks who are going to give you a good quality install. That's one. And then the other one I would just add to what Rob was saying, and finding the people who are actually involved in the industry and supporting the development of the industry as well. Those are the folks who care. And so whether it's their organization or some of their installers, or some of the people who may serve on a board with one of those nonprofits or whatever, those are the folks who are really working to achieve the good outcomes. And that's another sort of reference to kind of look for when you're trying to select folks from industry. My experience, that's a personal comment experience. So
Yeah, great. Thank you. All right, so we have a few questions in the chat. A lot of them are kind of home specific or project specific. So I'm going to maybe just focus on the more general questions first, and then we'll move into the specific home questions. So just a question here, if switching from a gas furnace to a heat pump system, does it impact the humidity levels in the house?
No, it's nothing to do with it.
So no.
No.
Nope. Okay. Perfect. And then, okay, so that was kind of the only general one there. That we have a few project specific, but I want to go back to that one of the first questions that came through around what you would recommend for DIY installations. We are going to come back to that one too.
Somehow I was hoping that one would go away. Correct me if I'm wrong. That's a do-it-yourself, right? Is it?
Yes.
Yeah.
Okay. I just, unless it's the simplest, ductless split, the pre-charged line set, that you don't have to do anything to. I don't know. I just, to me, it seems most incredibly improbable likelihood of success doing it yourself. However, having said that, there's people out there I've known that could probably figure it out because they do all kinds of mechanical stuff or technical stuff that may not be directly related to the HVAC industry. Could probably figure it out, but generally speaking, I would say do yourself a favor, get somebody who knows what they're doing, and don't do it yourself.
Yeah, and the only thing I would add is like I recognize that like there is some equipment that's coming out that is positioning itself in the market as do it yourself, and working kind of under those cost pressures to try to make it more accessible and less cost for folks to put in heat pumps. I aligned with everything as Rob is saying. The reason why we're doing these sessions and the reason why we're doing stuff with contractors is because of the issues with poor quality installations and unqualified people installing equiment. And
those are the contractors.
And those are the contractors.
Yeah.
Exactly. And so the thought of like, all of a sudden heat pumps becoming scaled with do-it-yourself installations is a scary prospect that I don't want to entertain.
Okay, perfect. We'll leave it at that. All right. Celia, she says she has a 95% efficient gas furnace. Her house is well insulated. Does it make sense to add an air-to-air heat pump to her existing furnace with the purpose of reducing gas usage?
That's a good question. Okay, so if your gas furnace is 95% efficient, it's relatively new, it's doing a great job. The question then comes down to what could possibly motivate you to spend the money to put a heat pump? Maybe you want cooling. What's the value of that? That has some value to some people in some areas. If you're missing cooling, you're getting, you're getting cooked out of your home. You're not comfortable in the summertime, and cooling would be nice. There's a value. If you are sensitive about your carbon footprint, it's different for everybody, right? What's that value? There might be a value there. Are you going to save money in operating costs if you get the right heat pump? Yeah, you'll save some money for sure. Will it pay you back your initial upfront cost? That's the hard part. Your good contractor or energy advisor should help you with that equation, because it depends on your house, your climate region, everything, right? It depends, on what your load is. If you can imagine, if it takes a lot of energy to heat your house, the sooner your payback will be. If you've got a very efficient home and it doesn't take a lot of energy to heat your house, the longer that payback, if at all, because don't forget that payback has to happen within the life cycle of the equipment, because you don't want to get to a point, well, okay, now I'm starting to save money, but whoops, I got to change all my equipment, right? It's got to happen within the life cycle of the equipment. So I think if it were me, my critical questions I'd want to answer for myself would be, do I want cooling? What's that value? Do I want to reduce my carbon footprint? What's that value? Is this a good time for me money-wise? Am I doing okay money-wise right now? Plus, there's an incentive out there. Maybe now's the time to do it, if I'm going to do it at all. Is it going to save me money? Yeah, it will. But, how much? That's a complex set of calculations that somebody knows what they're doing needs to figure out, unless you're, that type where you can work out the math. It's taken me my lifetime to figure that stuff out, so it doesn't come naturally to everybody. But yeah, those are the kinds of questions I would ask. So it's not simple yes or no. I'm sorry.
No, great insights. Thank you. All right. Anything to add, Ryan? Sorry, did I just cut you off?
No,
No.
that was
Okay.
good.
Perfect. Okay, I'm gonna, some of these questions are quite long, so I'm gonna be kind of paraphrasing them. So folks, if I'm asking one of your questions and you think I've missed an essential piece, let us know. Ken just asks, he is asking about installing an air source heat pump in a small, very well built new build. So would an air source heat pump and a natural gas furnace make sense in this scenario?
I'm sorry. I'm sorry. What I got the
It's a
new build
small,
part.
yeah,
Small
so
new
then,
build.
so
Yeah.
he's wondering, small new build, would an air source heat pump, so it would a hybrid or dual fuel, like an air source heat pump and a gas furnace make sense in that house?
It's a good question. Depending on the climate zone, um, you may be in a situation where there's only a very small, in fact, there's only a single product in the market right now that does lower than 36,000 BTUs as a gas product. It's a Detson. You can get those. So you're limited in the gas products um, to put in as a dual fuel or hybrid system. Um, I, I would, my biggest challenge would be how much room do I have on the panel? If it's a 200 amp service, how much room do I have for 40 amps, say, or 30 dedicated to the heat pump? And maybe, you know, a 10 kilowatt heater strip, right? Which is going to take another 40 amps. If I got room for that on the panel. If I do, the heat pump would probably all electric would be my first choice. If I have to upgrade that panel, that is not a step, it's a leap. It's a huge cost. That would pivot my decision probably to a gas furnace as part of the heat pump package.
Yeah, also where they located and the performance of the house that they're building too, because then you could get smaller equipment. And then if you're like, you know, in climate zone 4 or something, you know, you don't even need the supplemental backup that Rob's
Yeah,
like you can put in just the heat pump and then you don't have to load up the panel. So
yeah, then you're done. If you're in, yeah, so if it's a small house and it's a high performance house, it typically suggests that you don't need a gas system, you know, in most of our climate zones, unless you're way up in Fort St. John or, you know, in climate zone 6, for example. Maybe then it would be a consideration. But again, it depends on the size and the performance level of the building itself.
Rob, what are we typically doing with the sort of like laneway carriage homes stuff that we're designing?
They're usually very limited ducting, so they're concealed duct units or they're ductless.
Yeah, that's what I thought.
Yeah.
Okay, great. And I just put in the chat, folks, Rob and Ryan have mentioned a couple times about determining whether there's room on your panel to electric. Their last webinar series was on this topic of understanding and managing your home's electrical load. So I just put the link in the chat there. There's some strategies there on how you can.
Yeah,
Sorry, go ahead, Ryan.
there's a really good BC housing resource specifically for homeowners in understanding panels and capacity. Jenna, reach out to me after
Okay.
this, forget, and then we can send that out to folks. But
Perfect.
it's super good. It's written totally in consumer speak too.
Perfect. I'll include that in the follow-up email. Great. All right. Where are we here? So Bonnie, she shared her story earlier about a recent heat pump install that she's not totally satisfied with, and she just says we were talking about some icing, some frosting of the unit, and she says that her unit, there's an inch of pure ice on the sides and back of the unit, such that there is no airflow through all of the fins in the back. So why is there so much ice that the unit itself isn't seeming to get rid of?
Oh, well, that could be a number of things. My first impression is that what we're talking about here is a technical malfunction of some sort. It's not defrosting adequately, and it can be a compounding problem. You know, once you stop the airflow, it just gets worse. It kind of amplifies itself. So what you have to do is find what the source of the problem is. You know, so it could be a control algorithm. You know, why isn't that going into defrost as often as it should and as thoroughly as it should? You need a technician on site to answer that question and discover it, because in my mind, it is definitely a control malfunction of some sort going on there.
And is this a new install too?
Yeah.
It's a new install.
Yeah.
I guess it's no point asking for the commissioning report. That's what I'd want to see first. Okay, well, you know, when you commission the system, what was going on?
But that's definitely not normal behavior.
No.
So, like it needs some forensics.
Yeah.
All right. Thanks, guys. So we have about 10 minutes left here. We have about 4 more questions in the chat. So we'll do our best to kind of get through them here. And folks, while we're going through these last set of questions, I'm going to run a feedback poll. We do just get a little bit of feedback on the session and give you an opportunity to share other topics you're interested in learning about. So that'll run in the background, and we'll just continue on answering the questions. So another kind of home specific question. So this person, they just moved into a rental with a new heat pump system. Yay. I'm about to do the same thing. Very excited. Heat pumps are new to her, and her question is operational. So she's using it in heat mode, and it appears that the system wants to stay firmly in that set temperature. And if the ambient heat or the ambient temperature exceeds that set temperature, example through sun, from sun through the window, it'll start blowing cold air to maintain that set temperature. So she's just trying to understand what's happening there and if there's anything she can do to avoid this and preserve any free heat that comes into the home environment rather than kind of spitting out cold air.
Yeah, if it's in heat mode, it should not be spitting out cold air unless it's in auto changeover mode or auto mode, because the thermostat will sense that the temperature has been satisfied if that's what's happening. If the ambient, you know, solar gain, for example, is ramping up the temperature beyond the set point, the thermostat sensor should note that and say we're happy. The only other potential answer to that is that the fan is running in continuous fan mode or fan on mode. In which case, when there's not a call for heat, you will feel what is your ambient air temperature, which may feel cold to the touch, circulating around the space. So if the fan is in its on cycle, which we always recommend, it's room temperature air. It's not heated air. Right, that may feel cool to the touch, but if your thermostat is on heat only mode, it's not going to bring on cooling. If it's in heat only mode and fan is on mode as opposed to auto mode, then what will happen when there's no call for heating is that it'll just be recirculating air, which may feel cool to the touch.
Okay, great, thank you. All right, a few more questions here. So Kirk, they've been running a geothermal ground source system on a new build in Calgary for over the last 5 to 6 months. It's working really well, but it's noisy. So relative to their past experience with gas furnaces. So a couple issues here that he'd like your thoughts on. Firstly, the compressor is loud, both starting up and while running. And secondly, airflow seems higher and then because of that noisier. So any kind of thoughts there?
Yeah, well, you know, part of it is we have to make some assumptions. Like, say, we'll assume that it was sized correctly. If it's sized correctly, why would it be noisy? Well, it could be just that the selection of the equipment You know, they compete on various things. One of them, you know, there's some required than others. If it's a water furnace or climate master of one of the very common major brands, it shouldn't be noisy unless it's undersized or oversized, sorry. And the same is true for the airflow. If the ducting is not sized adequately, there's a lot of static pressure. That heat pump probably has a variable speed fan in it, an ECM motor, which will ride the static pressure. In other words, as the pressure increases, the fan ramps up, making it louder. That's the only explanation I can think of, unless the equipment is, you know, a lesser quality, higher decibel, or the system was oversized for the building. Of course, your loop field replaces that out, what would be an outdoor unit. So it's, you know, dead quiet. It's there buried in the ground. So it can only be those things. I think that what I would want to do is a external static pressure test on the ducting. Measure, you know, what's the duct doing, and is that impacting the compressor?
Great, thank you. All right, we have 4 minutes left and 2 questions left. I think we can get through these. So Robin just asks if there's a minimum climate zone temperature where a dual fuel system is recommended versus an all electric unit. So we mentioned Fort St. John maybe doing better with the dual fuel heat pump, but is there a, you know, a climate zone?
I don't think it's like a climate zone specific kind of like thing. It definitely dual
Yeah.
fuel in colder areas is a you know, I guess a more appropriate solution, but it really comes down to the home and the interests of the homeowner,
Yeah.
and other factors. There's no hard and fast rule in terms of, you know, climate zone 5, 6, 7 dual fuel and climate zone 4 no. It really is specific to, like, is it new construction or is it existing homes? Is there a limitation to the size of the heat pump that you can put into the existing home, right? And so you need, you know, you'd rather you know, you have limitations with panel capacity, so you go gas furnace instead of, like, you know, electric resistant supplemental. So it's hard to give a, you know, a black and white answer. Like, there's a lot of gray area there, but I would say generally speaking, especially where the design temperatures get lower, dual fuel makes quite a bit of
More sense. Yeah.
Yeah.
When you're in the cold climate zones, and it's a retrofit especially, that's where I'd be most cautious with all electric.
Yeah.
And, you know, probably default to a gas. But I would, even in those cases, leave my mind open. Maybe in this situation, we can do all electric, but that's in the coldest climate zones. But if we're talking about new construction, it's a whole different thing. We can have, you know, 2,500 square foot house in Fort St. James, for example, that has less of a heating load than a 2,500 square foot house in West Vancouver. You know, one is all glass with nothing but view, and, you know, it's, you know, built for looks and not for comfort, right? And the one in Fort St. James, same size, you know, it's built for its environment, and it could have less of a heating load. Then we see that all the time. So it's very nuanced. But I would say, generally speaking, the colder it is, the colder the climate zone, the little more hesitant I would be to do all electric. But I would never close my mind to it. I would just be a little more cautious.
Great. All right, we're going to squeeze in one last question here. Chris is a farmer on a rural property with a mobile home. So the only source of power is electricity on the property. The mobile home has ducting from a previous oil heater, and it's updated with new insulation. So any recommendations in terms of a new install in that mobile home?
So this would, and it's been updated with the new oil.
No,
It had,
oil furnace is out. Is that what
yeah.
they're saying? So they've got
Oh.
the existing,
So that, yeah, so that's probably ducting in, the flat ducting in the floor.
underbelly.
Yeah, underbelly ducting. Yeah. Well, you can put anything in there. The only thing that's typical trailers is that the ducting is a lot more restricted, right? So it's a little more important to make sure you've got the flow you need, but you can put anything in there. So you can put a, you know, a gas furnace with a heat pump in there if you wanted to, but just that, you know, with trailers, we've experienced that the ducting is a little more restricted, and the other thing is the quality of the ducting because it's more exposed. It tends not to stand up well over time compared to a more traditional home. This is something I know personally very well from living in trailers in Fort McMurray when they were just building Syncrude. I spent a lot of time under that trailer fixing ducting because and people caught on, and next thing you know, I was everybody's best friend and going to everybody's trailers and fixing those ducting. It was the same story all the time. You know, the ducting wasn't in good shape, and it was not as big as you would like it to be. So it has to be checked. But as far as the equipment goes, it's notwithstanding the condition of the ducting, anything can go in.
The only thing I would add, Jenna, I don't know if we can share it, but we did those presentations on this exact topic because we're because there's various retrofit activity. Manufactured homes are fascinating. There's various retrofit activity happening around BC, doing like under duct repair and remediation because we find like collapsed ductwork, disconnected joints, like just all kinds of stuff. Which is the nature of them. And then we're doing both ductless systems, even multi-zone, and also now where we can, putting in forced air central heat pumps with the existing ductwork. But again, it comes down to like testing and duct sealing and doing duct repair and then putting in the system for all the reasons that Rob was saying. But those presentations have like those could be helpful.
That would be a great resource, to pass on. I think that would be
and
really good. With a whole presentation just on that subject.
Yeah, and then
it's in the.
Yeah, and you can probably get a hold of us if you want to ask another question.
Great. Yeah, I just put the link in the chat. You were I had that up already. We were little symbiosis there. Yeah, perfect. All right, with that, we are just a few minutes past time. So I know there's some more questions that are coming through the chat, but sorry, folks, we only had 90 minutes today and there never seems to be enough time for questions. But thank you so much, Rob and Ryan. I really appreciate you taking your time, and thanks everyone on the call for joining us tonight. And I hope you enjoy the rest of your evening.
Thanks a lot, everybody.
Thanks, Jenna. Thanks, everybody.
Thanks, Jenna, for hosting.
Take care.
As always, bye.